You need to accumulate $10,000. To do so, you plan to deposit $1,250 per year into a bank account that will pay you an interest rate of 12%. Deposits are made at the end of the year. Your last deposit will be less than $1,250. So how many years will it take to reach your goal, and how large will the last payment be? So probably the key things to identify here is you're making a series of payments. They're at the end of the year and they're earning a rate of return. And at some point this cash flow will end. So you're finding the value of an annuity. But remember, you're not finding the present value of an annuity. You're finding a future value because you're saving to eventually get to this amount of 10,000. So what you're trying to find in this question is the future value of an annuity and not the present value of an annuity. So the future value is 10,000, the payment is 1,250. The rate of return on the bank account is 12%. T is your unknown, as well as your last payment is the unknown. So how many years to solve for T? So what we're identifying here is this. 10,000 is our future, our payment is 1,250, and we'll just set this question up as the formula up here shows us. It's 1 plus R, so 1 plus 12% results in 1.12 to the power of T, then subtract 1, divided by the rate of 12%. We simplify by moving the payment over to the left-hand side, and now we have 8 is equal to 1.12 to the power of T minus 1 divided by 0.12. We'll then multiply both sides by R, and we're left with 0.96 is equal to 1.12 to the power T, but we also at the same time will also add 1 to both sides as well. So now we have 0.96 plus 1 is equal to 1.12 to the power T. From this point it should be pretty easy. You can identify that you have to take the natural log of both sides to pull the exponent down, and then we'll move the natural log of 1.12 over to the right hand side. So we have the natural log of 1.96 divided by the natural log of 1.12 is equal to T, and we find that T is equal to 5.937 years. So what this is telling us is we're going to have to make 5 payments of 1,250, and then there will be a partial payment at the end of year 6, and that will bring us to the full amount of 10,000. So what does this look like then in a cash flow? Well, we want to ask ourselves a few questions. If our cash flow looks as such, we're going to have a payment at year 1 of 1,250, a payment at year 2, 3, 4, and 5, and then a partial payment in year 6. So we have an unknown here. But what we want to know is what is the future value at the end of year 5? And so we can use this same future value of an annuity to tell us at least at the year 5 how much money we will have. And so that future value is equal to our payment times the inputs, the 1.12, that is the rate of return, 1 plus the rate of return that we're getting on the bank account, to the power of 5. Remember, we're doing it 5 years forward, not by all the way at year 6, minus 1. And we find that that is equal to an amount of 7,941.06. So what this is telling us, at the end of year 5, our account will have a balance of 7,941 and change. But then we also need to realize that at the end of year 5, this amount still has 1 more year to grow. So we want to know, what will this amount grow to at year 6? So we take that amount, multiply it by 1 more year in rate of return in the bank account. So if we leave this 7,941 in the bank account and it's growing at 12%, how much will we have by the end of year 6? And at the end of year 6, we're going to have $8,893.99. So what this tells us then, to get to $10,000, we need to add a final payment to this amount so that we reach our goal of 10,000. From here, the math is fairly straightforward. We have our 10,000. We subtract how much we've saved up to the end of year 6, that $8,893.99, and we find that we need to make a final deposit of $1,106.01 to reach our goal. What does this look like in a table? Well, our deposit at year 1, we have nothing at year 0, and at the end of year 1 we deposit $1,250, but that's at the end of the year. So this amount only grows in year 2, so our initial deposit at time 1 will grow to an amount of $1,400 by year 2, and at the end of year 2 we're going to deposit another $1,250 for a grand total of $2,650. This process will repeat into the 3rd year. The original $1,012.50 we deposit now will have grown to $1,568. The amount that we deposited at the end of year 2 will now have a value of $1,400 at the end of year 3, and we'll also repeat that process of making another deposit of $1,250. By the end of year 3, we'll have a balance of $4,218. We repeat this process up to the end of year 6, and at the end of year 6, we again identify that we'll reach a balance of $8,893.99. So at the end of year 6, we've reached this amount, and we need to make one deposit at the end of year 6, which is $1,106.01. We'll say its final deposit is equal to this amount, and we now see we've reached our goal of 10,000. So hopefully that helps clarify this question. I know this question sometimes tends to be difficult to interpret, but this is the cash flow at work.